Hello and welcome here to this video. It's a pleasure for me to see you here and what we want to talk about. Today I want to talk a little bit about the functional approach inside the core JDK, or how you can code in a functional way with the core JDK without any other library. So if there's something for you, then you're right here. By the way, my name is Sven and I'm developer advocate for JFrog, living in Germany, and as you can see, mostly I'm out in the woods. So if you saw any other video of mine, then you will see that I'm mostly somewhere in nature and I just love it. So if you're interested in having more videos in this style about Java, DevSecOps, cybersecurity, check out my YouTube channel, please. I really would love to see you as my new subscriber. But now we want to start with the topic functional with core Java. So why we want to code in a functional approach? So the main thing is Java is an object-oriented language, but what you can do is you can have some functional aspects and code Java with a functional approach. So I'm not telling you here how the pure functional world is now mapped to the Java world, but I will show you different aspects or different strategies, what you want to reach with the functional programming, and how this can be translated in easy and straightforward way into the core JDK, so that you can use these approaches in your own project without losing the connection to the object-oriented world, without losing the possibility to use it in a small part inside your project, and the main and most important thing is without adding a huge functional reactive library that is just bringing new type systems, new paradigms and all this stuff. And so just to give you the possibility to code in a functional way, but without vendor lock-in. The first thing I want to talk about is the optional, because one of these aspects inside the functional coding is get rid of null. So you have to give always a value back, whatever it means, but no exceptions and no null. So there's one thing. So since JDK 8 we have this optional, and this optional is okay. There are some limitations I will cover in a few minutes, but it's okay so far. You can create an empty one, you can create with a value one, then it's typed, and then you can say, okay, maybe I have a null, maybe not, so you can off nullable, so the thing, so that you are passing from something that is delivering maybe null to something into an optional without this if null then create something approach. So this is okay so far. To get values out, you have this method if present. You don't have an if absent. I will come to this in a few minutes, but you have this if present method so that you can ask if there's something, you can get it out. Or later in JDK 9 you have something like make a stream out of it with just one value. So this is okay. Why this option is so important? The option is important, first of all, you're getting rid of this null thing. On the other side, it's a very good bridge between the object-oriented code and the functional code. And if you have bigger projects already, you have some object-oriented code, and then it's good if you have an easy way to switch between both worlds without having this huge layer. And this optional, or later the result, what I'm covering in a few minutes, is a very good approach here. So if you have the value and you have two possible ways, so there is something or there's nothing, you have this if present or else construct, so that you can give two actions that should follow, but you're not grabbing this value out of it to do something. So you're really working on this holder, and then you can decide I'm presenting pass for there is something, or I'm presenting something if there's nothing. So functional means that you're transferring or transforming values, and this means inside the optional you have this map method or flat map later, so that you don't have this optional approach, but you have this map, and then you're providing transformation. Later we're calling it function, and then you can do it. You can filter, you can do all this stuff. So that's okay. So you can do a few things. One thing that's not so nice, it's against the functional approach, I will cover this in the section about exceptions, is that you can throw exceptions, and one functional approach is catch all exceptions, don't throw them. Later we are covering this one. So this is not nice inside the optional, but it is there. So why we should think about extending it? First of all, to get rid of the weak points, and the second thing is, if I want to extend the optional, I have to implement something because the optional itself is final. So I think the optional itself is not symmetric enough, because you have something like if present, but you don't have something like if absent. Later, if you want to connect to the reactive world, then you have no way to do this in an easy way, but it's easy to implement there. By the way, I'm not covering here the reactive part of this talk because I don't have enough time. So if you want to see the extended version, check out my YouTube channel. There's an extended version of my talk about the functional reactive part, and on my website you will find the slides anyway, if I'm not able to put it here straight to the talk. So, okay, one thing, if you're talking about start coding functional in an existing project, make sure that the API you are creating is not only fulfilling the functional approach, but the object-oriented approach as well, just to make it convenient for all of your colleagues, and that you don't have this very hard layer between these two approaches. But we will come to this in a few minutes. So I'm calling my implementation result, so that's very obvious. That's not the original optional, but it should be implemented as a drop-in replacement so that you can get rid of it very easily if the optional will fulfill the needed requirements, what you are using, or. So then it should be easy to transfer between optional and result and optional, so that this is a very easy thing. And yeah, it should be very symmetric. What does it mean? So, for example, to transfer between optional and result is very easy. You have just method like to optional or from optional, so that's a very easy thing. And then the symmetric thing is make sure that the API is always like result a successful thing with a value or a failure with a message. And here is the first improvement against or compared to the optional. Deliver some, have the possibility to deliver information even if there is no value. Inside the optional you have just null. Here you can deliver a text, a stack trace, whatever. So you don't have value, but you have information, what was going wrong. So symmetric means if you have something like if present, then you should implement immediately something like if absent, so that you don't have the boilerplate code with if not present and so on and so on. And yeah, you can handle both ways with if present or else, but the optional is offering this one as well. So if you're implementing this drop-in replacement, the easiest way is just create a new class, copy all signatures from the optional inside so that you have really the same signatures, and then start extending it. It's mostly the easiest way. What I'm missing at the optional is just we have this map method. So I have this value, and then I can apply a transformation. But if you want to combine it with different values, the option itself, I have to get this value out, then I can combine both, then I have to wrap it again in optional. That's not nice. You can think about combining something, what you can see inside the complete future. So then combine, or what's called, then combine is a method called in my demo implementation. And then you have this optional, this wrapped value. You're providing the next value, and you're providing a transformation for both. So this makes it very easy. And think about that in the functional world, a value is not only a value like boolean, int, whatever. A value could be a function itself. So make sure that you think always in terms of providing a function as a value itself. Okay, that's a short version of extending the optional. Now we are covering the next topic, and this would be how to get rid of exceptions. The next thing is dealing with exceptions in Java. So Java has exceptions, checked one, unchecked one, and this is sometimes not so nice. And the functional approach here is that catch all exceptions but don't throw them. So in the functional approach you have no exception, because this is just leaving the path you should go. So let's assume we have an example like parse in. So what should I do to catch all exceptions, and how it looks like. So if I have this integer that parse int, and I'm putting something in, then it will be for example a number format exception, and the thing to get rid is the try catch. Okay, so the next thing is if you're using this inside a stream during the map phase, for example, you can use this integer that parse int something, but if you're providing the wrong value, then it's just terminating the stream because you need something. So the first thing is, again, we need this try catch because we want to catch all exceptions. That's one thing, but what we are giving back? If we are giving back something like 0 because we want to parse an int, it would be okay if we are summing up all the integers close, but if we need something different, then it could be that this is just wrong. So we need to wrap it. We had this with an optional, so we have to identify, okay, if there's an exception, then we have to wrap it in something like an optional or the result and how it looks like. For example, if you have now this map phase and you have then this try catch block and giving something an optional back, then you have to unwrap it and so on and so on. And this code is not nice. So how to get rid of this? To get rid of this means we have to think about what we are doing with this try-catch block. This try-catch block is something that's very repetitive, and if I have different map phases in a stream, I have try-catch, 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 I want to get rid. So how to extract this? This could be done with a checked function. So a map phase is nothing else as a transformation from A to B, and now I want to have a checked function. A checked function is the same as a function from A to B, but including this wrapping mechanism to give a holdback. So a function from A to B would be transformed to a function to A to result of B. And then you can put all your try-catch block in. And the thing how to do it is more or less inside the functional interface. What you're doing, you're defining a method apply with exception that's able to throw an exception. This is a method signature you have to implement, and you're providing a default implementation for the checked function where you're doing all this, applying with an exception, wrapping this try-catch around. If there's something, wrapping this into the holder, the positive example or the positive value inside the result. And if there's something going wrong, then you're grabbing the stack trace, creating a negative or a failure of this result, wrapping this message in and delivering this one. So with this, what we have is now the possibility to work with the checked function. We have this automatic wrapping, we have this information that something is going wrong, so we can decide later what's going on. So what do we have with this? If we have this checked function immediately, we have the possibility to create a checked consumer. It's exactly the same, because the checked consumer is a checked function from T to void. That's a checked consumer. The same is with a checked executor. If I want to have a checked executor, then it's nothing else like a function from void to result of void, because it could go something wrong. You're delivering this message. The other thing is for a supplier. We have now a checked supplier. A checked supplier is a supplier, not a supplier of type T, it's a supplier of result of T, and you're doing exactly the same. So with this, we have now the possibility to catch everywhere there's exception. We are able to extract this try-catch block in a way that we are not writing it always, but it's very explicit, and then we can deal with this value, this non-null value, and we can deliver the information what was going wrong. So catch all exceptions, never throw them, is one functional approach. Now I want to talk a little bit about the basics dealing with functions. So we have different things. So first of all, what is a function? A function is something like, mosquito? Okay. A function is something where a value and type will be transformed into a different value with maybe a different type. So that's a function. And in the original functional approach, it's always one value in, one value out. Okay, so if I am looking at different code that is using functions, for example, I see quite often that people are writing down, oh, I need, for example, the function x plus 2, x plus 10, x plus 5. Now I have different questions. First of all, makes it sense to write all these variations down. The second question is, where's the right place to define a function? So because I don't want to redefine this function if I'm using it in several places again and again. And how to use this function. So quite often I see that these functions are used like an object with a method, so that you have this, I'm applying function A, getting out the value, of applying function B, getting out the value, and so on. Or they are chaining it like function A apply with function B apply plus function, and so on and so on. So they're chaining this code. Both approaches are not nice, so how to deal with this? In the functional world, we have this approach of combining functions to other functions. So a function A and a function B and a function B, they are composed together so that the result will be one function that is indirectly applying all those functions. So, and we have two ways in Java to do this. And the first one is compose, and compose is just a disaster because you're mostly running into the limitation of this type interferencer, because there is something that giving me some type back, and this is my high input, and the type interference in Java is just not able to handle it. In my extended version and in my slides, I have an example to show you how to build a higher compose based on this approach, and this is nice to see it once, but nothing for production. The other way, what you should do is you should always go with approach and then. With the approach and then, you're chaining another way. You're saying, I'm the function and my output type will be this type, and then I'm activating the next function. So you're concatenating the function and then and then and then. And this is way easier for the type interferencer, because then he knows, or the type interferencer knows, this is the output type, this is the possible input type, and so on and so on. So you should do this. Next question, or the previous question was the right place to define these functions? Mainly I see it inside the code, and that's not good, because I'm just writing down, okay, now I need a function, then I'm applying it, then I'm throwing it away. But in the functional world, you should pushing abstraction to the limit, and you should do it in a way that you're defining stuff exactly once and then reusing it. A good place to place implementations of a function that are generic, that you're using everywhere, is inside an interface, inside a static method, because then the method, the return value of this method, is an instance of this function. So if you have an function plus 2, x plus 2, then inside an interface create a static method, functional, and then some name, and the return value is a function that is adding constantly 2. So if you are doing it now with this plus 2, plus 10, plus 5, the next question is how to get rid of this repetitive code. And inside the functional world, pushing abstraction to the limit means describe what you need instead of writing down what you need. And the fine difference here is, instead of writing down, I need something plus 2, plus 10, plus 5, I need something that is able to create a function that can add a constant value. So it's a different approach to describe what you need. Okay, I need a function that is able to add a constant based on what constants I need right now. So I need a function called adder, and this function will give me, based on an input type, a function as output type. So it's not only a type and value in a way like boolean, int, and so on. The return type could be type of function, and the value is an instance of a function. So here is a method adder, and the return value will be a function that is constantly adding a value. So with this, you're now able to describe in a more abstract way what functions you need, and you found a place, or you have a place, where you can put all this stuff inside interface. You can use it via inheritance, you can use it via static imports, and so on and so on. And now, instead of having plus 2, plus 10, plus 5, I have now adder called with a value 2, adder called with a value 5, and adder called with a value 10, and then I have my 3 functions, and I can compose or whatever, or I can do it exactly with a method call. The next thing I want to explain is this term currying, because we needed to connect to methods with more than one input value to connect to the object-oriented world, and we have sometimes the need to have multiple input values, and then how to deal with this. So the functional approach is that you are reducing the complexity or the dimensions of the function of higher functions or higher order functions to something that's one-dimensional, and then searching for solution just for one dimension, and then you can scale back to multi-dimensional challenges. So here, what does it mean? If I have a by function in Java, this is not a functional approach, because I have 2 input values, a transformation, and 1 output value. But I need sometimes multiple input values to do something with them. So the functional approach would be, first of all, that you say, okay, if I'm currying means a by function transferred to a function, just 1 input value, transformation 1 output value, means I need, first of all, a function that is grabbing the first input value and giving me back a function that's holding internally the first input value, getting the next input value and transforming it and giving back a value. So the output for the first function would be the function itself that's getting the next value and then calculating the value itself. So you have a function, and then the output value. So you have to, maybe if you're not familiar to this, maybe you have to read a little bit about this to get around this. But this is more or less what we're using for memoizing in a few minutes as well. So this currying and uncurrying. The good thing is you can do it in a way to bifunction to a curried function, and from a curried function back to a bifunction. If you solve this for a bifunction, you can do it for a trifunction, quad function, and so on and so on. So you can scale in dimensions. And this is good because sometimes in the object-oriented world we have multiple input values, 3, 4, 5, 6 or whatever. Then we can make, for example, for 3 input values we could create a trifunction. It's just call it a trifunction, copy paste a bifunction and extend for 1 dimension. Then you have a trifunction. Then you're currying it. Then you're in your functional world. You can do all the things in your functional world, and then you are uncurrying this one back to a trifunction. And this is possible to be applied by an object-oriented method with more than 1 value. So here in this case with 3 values. So this is currying and uncurrying. And yeah, the first usage of this is, for example, memoizing higher order functions. Let's talk about memoizing. Memoizing means that a function that is called twice will give you, if you're calling a function twice with the same input value, we will get exactly the same output value. So that's a better definition. It means that if you're calling a function and the result is 2, you're calling it again with the same value, then you will get 2 as well. So within the Boolean and so on is no challenge. But what is, if the return of the function is a car or whatever instance of your own class, it would mean that if you're calling with the same input value, you would get exactly the same instance, not a copy, a different instance of the object of the class with the same values, but really the same entity, the same instance. So how to do this? The first approach is that we are doing it in a way that we think about a memoizer as something that is able to remember. Remembering something based on input value is a hash map. So we have a concurrent hash map, and then what we are doing is to add the cross-functionality memoizing to a function is we are wrapping this call of a function into something that is asking first the hash map if there's something. So what we're doing is around this invocation of a function, we're just calling the same thing with first the hash map. So in a way that we are saying, okay, concurrent hash map, compute if absent, and the return value is what you're giving. So if it's invoked the first time, then we are using the function itself to calculate the value, storing it in a hash map, giving back the value. The second time we're just looking up in this concurrent hash map, and voila, we have exactly what we need. So the next thing is how to do it with higher order functions. So if I have bifunctions, if I have, and so on, then what we can do is we can use exactly this currying approach, what we had before. So if I have a bifunction, I just currying this function, and then on every dimension I'm invoking the memoizing. So if I'm activating this one, what I have is now they can decide in an one-dimensional function if I have something like a caching. So memoizing, you can say caching to it more or less. It's not correct, but let's say let's use this term of caching. So you have partially caching on a function, and then if you have a multi-dimensional function, a bifunction, a two-dimensional function, a higher order function, then you would have the choice to, for both input values separately, decide if you are caching yes or no. And this you can do with a try function and quad function and so on and so on. So here you see the one-dimensional solution of adding memoizing can be scaled on multi-dimensional functions or on higher order functions if you're currying this function and then applying this memoizing on each level if it's necessary, yes or no. And what can we do with this? There's some interesting thing that we can see. First of all, this memoizing and unmemoizing, we can do it in both ways because we are not touching the original function. We are just putting something around, so we are not touching the original. So I can unmemoize more or less in the same way that I'm giving back the original function. And the other thing what I want to highlight is that if you have, for example, old legacy code with, for example, a method with one or multiple values, we can curry how to connect to the functional world. If you're doing this approach that you're extracting from a method, the dynamic method reference, then you can immediately use it as a bifunction. So you have an object with a function, you're extracting the method handle for this, then you have more or less exactly a bifunction, something with 2 input values, 1 output value. If the original function has, or the original method has 2 input value and something will be calculated. And you don't need a typecast or whatever, because you're just going over this method handle thing. And the cool thing is, you don't have to touch all legacy code to go from a method with 2 input values to a bifunction. You can apply, you can memoize, you can do all this stuff, and you're not touching the original. So you can just add for your part of invocation this memoizing effect, and then getting rid, because you're not touching the original, giving back the original, or just throwing your own instance away. So this is a quite cool approach. First of all, memoizing. Memoizing is something where we are needing currying to get from higher order functions to one-dimensional functions, and this approach that you're extracting from legacy code, this method handles and method references, and with this method references you can then immediately switch to the functional world and reverse. And one thing that is mostly very interesting if you want to go to the functional world is how to deal with this object-oriented approach, switch, if then else, or this asking sign or whatever. So how to navigate through different passes. So what you need is an approach that will reduce the complexity, for example, of if then else and inside if then else and so on, to something in a linear list. And here I call this case or match cases. First of all, what you need is a case. A case is an extended pair of a supplier of a Boolean and a supplier of a result of T. Because what we need 2 methods. Is matching, I'm responsible to do something, and give me the result method. So these 2 methods we need. And we need this holder, because we have the decision, I'm now the right thing, and then how to calculate it. So we have the decision on one pass, and on the other side, or on the one side the decision, on the other side the calculation itself. So the transformation, how to get this result, is inside this result method. It will give back in an holder, optional, or preferably here in my case, result. So, and then you have the possibility to test the transformation. Okay, this is a transformation, there's a result, done independently. Then I have the question, what is the right time to activate it? So case A, B, C, D, E, F, G. So if the value is 1 or 2 or 3 or whatever. And then I have to give the supply of Boolean, it's something like a predicate. No? So just to decide, now it's the right time for me to do something. I implement it with a supply of Boolean, because if I have a bunch of these cases, and each case is the condition for the calculation and the calculation itself in a linear list. So I can provide case, 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 instead of having this concatenation of if then else things. Every decision can be as complex as needed, but I have a linear list of this is a decision, this is a calculation, and the implementation of it is just collect all these cases, define a default case. What is if no decision is done, so no dedicated case. So you say, okay, if it is 1, if it is 2, it's 3. In all other cases, the default case is whatever. And then what you're doing is just iterating over the stream of these cases. The first one that is matching, this is done with this supply of Boolean. We'll say, okay, now I'm the responsible one. From this one, you're catching the result and delivering it as output. So this match case is a very easy thing to navigate through different passes in a functional way, because you are applying just a decision, just a function, it's stateless, and so on. And you're getting rid of the whole if then else switch or whatever construction to deal with different variations of your execution path. So I hope this was a good approach for you or something that you want to try out, I have all this stuff done in an implementation. It's called Functional-Reactive library on my GitHub account. So go to Sven on GitHub, and then you will find this Functional-Reactive implementation. There's this reactive part as well. I'm not covering this here because it's just not enough time for it. But you will see all the implementation of this results, this match case, and all this stuff. And yeah, it's open source, so feel free to grab it. Let me know what you think about it. And yeah, and there you will find the slides as well. I think inside the repository you will find a PDF of the slides as well. Okay, we had now a few things about the functional approach, and I focus mostly on a practical approach. So how to get rid of null with the optional, or better with the results, their own implementation. It's just a few lines of code. We had this, how to deal with exceptions, so catch all exceptions, don't throw them, and how to extract this try catch block in a way that you can use it in multiple ways without even declaring it. We had the basics of functions, so how to deal with function, how to concatenate function with and then instead of compose. What's the right place to write down the implementation of functions, how to describe in a more generic way what you need instead of writing down all the different variations of a function you need. We had this currying of functions, how to reduce the complexity of a function back to a one-dimensional one and reverse. We had this memoizing, thinking what I calculated already and delivering the same instance back. And we had here this case, how to deal with different paths inside your functional implementation. I hope this helped you a lot to get up and running with the first functional approaches. Don't forget that you have an object-oriented approach itself, so never write code in a way that you are not able to use it with an optional approach without ugly wrappers. Make sure that if you're designing this API, it's suitable or it's usable for object-oriented approaches as well as for the functional approach. And one thing, in the functional approach, mostly you're using this immutability approach. This is not available in Java, so have in mind that all approaches with I assume this is immutable is not really safe in the Java world. But it will give you the first approaches to deal with the functional aspects. You can remove a lot of boilerplate code inside your projects with this, and the implementation itself, you can grab them from my GitHub repository if you want to have them, or you can implement it by yourself with just a few lines of code. It's just really a few hundred lines of code, and then you have all of this implemented with core Java inside your own application. So I hope you enjoyed it. If you like this one, check out my YouTube channel and subscribe it if you want to have more about core Java or JVM related stuff, as well as cybersecurity and cyber defense stuff. So I really would like to see you as my subscriber there. And that's all what I can say here in this amount of time I have. Thank you very much for watching, and stay safe and see you soon somewhere on LinkedIn, Twitter, whatever. Feel free to contact me.